Today we're going to be talking about maximums or minimums. An interesting property that comes up a lot when dealing with both functions and graphs of functions. Maximums and minimums exist both in the world of algebra and in the world of geometry, as we're going to see here. So these two terms emerged when mathematicians started graphing functions. And while graphing functions, they noticed certain relationships. Like, hey, there are certain points where, for the entirety of the graph, there's no y value. There's no point that's higher than this point, than a given point, right? So we can look here, we can say, hey, there is no point that has a greater y value that's higher up on the graph than this point. We can look at this point and say, hey, there's no point that's lower than this point on the entirety of the graph. The mathematician said, that's pretty interesting. I'm going to need to make a term for those. So what they call these terms were maximums and minimums. And when referring to the entire graph, they call these absolute or global maximums and minimums. Points where there was no other point in the entirety of the graph that was higher for maximums or lower for minimums. So, right here we would call an absolute or global, the terms are interchangeable, depends on the textbook or the teacher, minimum. And this right here is an absolute or global maximum. And that's all well and good, but soon mathematicians realized, hey, we're not just dealing with entireties of graphs. Sometimes we're looking at a certain section of the graph. Right? Sometimes I might be looking at all the non-negative parts of the graph, or the parts of the graph where my x values aren't negative numbers. Right? So basically from here out to here. And while I'm looking at that section of the graph, I can say, hey, I can kind of perform the same process of finding maximums and minimums that I did when looking at the entire graph. But the minimums and maximums that I find won't be for the entire graph, they'll be for this interval. So they said, okay, well we can do that. We'll call these relative or local maximums and minimums. Relative or local to a given interval in a given neighborhood. Right? So in the neighborhood of non-negative numbers, what's our maximum? What's our highest possible point? Well, we look here and we say, hey, at 0, which is a non-negative number, we hit our highest point. So we'll call that our relative or local maximum. Now we'll look for our lowest point. We actually find, hey, it's this point down here, right? That's okay. You are allowed to have points that are both absolute or global minimums or maximums, or relative or local maximums or minimums. This then is our relative or local minimum in the neighborhood of non-negative numbers. But now that we've got that down, let's say we throw in a curveball, right? So we'll look back at our graph. Right here we have our absolute maximum. And let's say I do something funky, right? Let's say instead of this making a point like it was, I make it an arrow. When we see an arrow on graphs, we know that they mean we're going on for infinity. We're going onwards and upwards for infinity. Now, this presents a little tricky solution, right? Our point that we could point out and say, hey, this point is our absolute maximum. It's no longer the absolute maximum because there's an arrow now. Does that mean our absolute maximum is negative infinity, right? Somewhere way up here? Well, no. Because if we were to graph we negative infinity, we couldn't. We cannot graph infinity. It's simply too big. For every point that we could graph a point greater. So, when we're given situations like this, we have an arrow going upwards, and there's no other curves, right? We said that there is no maximum. There is no maximum because we can just keep graphing greater and greater and greater. So, we're now going to go into other cases where we have interesting properties. where maximums and minimums don't really exist like we would think they would. And we'll go over why they would exist. So let's go back to that infinity issue, and let's make that a little clearer. Right? So imagine I have a graph like this. And then, right, we're along the y-axis, I go down for infinity and up for infinity. Do I have a maximum or minimum at infinity or negative infinity? Well, no, because I can't actually graph any of those 2 points and know, okay, the graph stops there, right? If I graphed 9 billion, well, I could graph 9 billion and 1, and that'd still be 1 point greater. So in these cases, when we're dealing with arrows that go on for infinity, right, and that's our graph, we don't have a maximum or minimum for that arrow. And that maximum minimum is not infinity. It simply does not exist. Another case where we don't have maximums or minimums are in situations where we have lines without endpoints, right? So here we have just a simple vertical line, but you'll notice I have open circles at the ends, meaning that if this was 1 and this was 7, the graph doesn't actually pass through 1 or 7. So what is my maximum minimum? If these were filled in, that'd be kind of easy. Oh, the graph is highest at 7 and lowest at 1, right? So my maximum is 7 and my minimum is 1, both absolute and relative. But that doesn't really work because these are open circles. So they don't exist at those points. When they don't exist at those points, we might say, oh, well, we just go one down and we find our absolute maximum, right? So our absolute maximum is just 6.99. Well, that doesn't really work because I could also graph 6.999, and that would be a little higher. If I could graph 6.99999, that'd be a little higher than that, and on for infinity. So when we have open circles here at our maximums or minimums, we simply do not have them, right? Because we could keep going infinitely closer to those points, and we could keep going higher. So, but since we can't actually get to those points, we can't actually have that highest point that we would want. So for those cases when we have open circles, no maximum, no minimum, when the minimums are when the open circles are at those maximums or minimums. So that just about sums up maximums and minimums, how they work in situations that you might encounter them, and edge cases or unusual situations that you might have to deal with them. I hope you enjoyed, and I hope you have a great day.